Okay, a sentence about me first. My name is Revanth of third year CSC, and I'm a member of CS Gang. That should be enough. Okay, today we'll be learning about queues and priority queues. An easy session. Okay, we'll just without any delay, we'll move forward. Okay, in the last week we have seen vectors as well as stacks. If you did not attend that session, I highly recommend you to watch that video. It's on YouTube. If you want the link, I'll leave the link at the end of the session. Okay, moving forward. As I said, we'll be discussing about queues and what their implementation in C++ and a couple of problems solved. Okay, what are queues? A quick Google search will give you this definition. Queues are data structures that follow first in, first out. FIFO, the first element that is added to a queue is the first one to be removed. Okay, it's not useful for newbies. Let's first discuss about some example and come back to this definition, shall we? Okay, look at this example. It's quite messy, I know. This is a queue in supermarket. If you observe this carefully, we have on the left side an entry point, and on the right side we have an exit point. So a queue has an entry point and exit point. And if we observe, we can observe one more thing. The first one who enters into this queue will be the first one to leave, right? Yes. And what observations can we make here? I think that's it, right? Okay, we'll move on to more programming oriented example. Let's see this. If you look here, we have rectangular blocks. Okay, the central part is a queue. As you can see, it has a back. In the previous example, it was entry point, and it has a front. In the previous example, it was exit, where people pay and exit. So a queue has a back and a front. Here we are seeing two new things: enqueue and dequeue. Well, enqueue is a function which lets you insert a new element into the queue. It's like just inserting a new element into the queue, and where it enters is at the back. And dequeue, just like enqueue, is a function which removes the element from the queue. As we have, you can see in this example, the first one to enter will be the first one to exit, right? So dequeue is a function which is performed on the on the front. You get it, right? So if we come back to that definition again, queues are data structures that follow first in, first out principle. The first element that is added to the queue is the first one to be removed. Now it kind of makes sense, right? So we'll just move on. That's it, guys. This is queues. And we'll come back to the implementation part in a moment after we discuss about priority queues. And okay, let's move on to priority queues. Okay, what are priority queues? As the name itself suggests, a priority queue has the elements in the priority queue has a priority, has a value to, has a priority to it. So they are just normal queues, but every element in the queue has some priority. So the highest priority elements which are present in our queue will be exited first, will be removed first. If you look at this previous example, this supermarket example, here they have no priority. I mean, or we can say that they all have equal priority. The one who enters first exits first. But in priority queue, the one who enters with highest priority, they will be the one to exit first. So highest priority will be processed first. So if you look at this example right here, let's assume, wait, let me give another example for priority queue. Um, mm, Assume that you're going to an event, some event, and you're in a line, in a queue. You're waiting. You know how queues are slow. You're slowly moving forward. So then there comes a guy from behind. Just like that, he was able to enter, the hall before you, before many other people. What happened here? Anyone has any guess why he was able to enter, before every other one? You can type in the chat box. Yeah, VIP. Yes, someone said VIP. Well, yes, he's the guy, the VIP guy, the politician guy, some guy with a background, with highest priority. He got the highest priority than you, so he entered the hall first. I think priority queues are clear now, I hope. Let's move on to another example. This is more program oriented, computer CS oriented. Let's assume you have a queue. Queue is nothing but an array. Okay, you have a queue. So in priority queue, you are first inserting 4, right? Here, if you look at here, you are inserting 4. There are no elements initially, so we just enter just like that. When you NQ8, NQ is nothing but, as we have discussed previously, it's nothing but entering items into the queue. When you NQ8, 8 is compared with all other elements in the queue. Now in the queue we only have 4, so it is compared with 4. 8 has much less priority than 4. As I said here, 1 being the highest priority, then plus infinity is the lowest priority. So 8 has lower priority than 4. And when you NQ1, see, 1 being highest priority, it should be on the front. It should be the one to be removed first because it has highest priority. You get my point, right? So it is pushed here to the front. Now if you look at the next NQing 7 and 3, they just follow the same above procedure. Priority of 7 falls behind 4 and priority of 3 falls behind 3. And after NQing 3, if we are to remove the element, then we can only remove the first highest priority one, the VIP guy to say. Okay, let's jump into implementation part, how we are going to implement that in C++. Okay, first let me remove this part, sorry. Okay, first let's discuss how we can implement queues in C++. First, we have a header file. If you want to use queue, then you need to include this header file. It consists of a bunch of queues, different types of queues, priority queues, double circular queues, like that. Queue, okay. Queue takes a data type. It can be anything. It can be your class. It can be existing data types like int, float, something, a string. We'll take int for now. Now let's call it queue. Let's just call it queue. As I said before, queue has two main basic operations. It has enqueue and it has dequeue. Right? Enqueue means it's nothing but pushing. We push the element to the back, and dequeue means removing the element from the front. So enqueue here is push. we are pushing 1 into the queue. And let's push some values, 2, 3, that's enough. And pop is nothing but DQ. So let's see what all the operations we can do on this queue. We got push, we got back. Back is nothing but back of the queue. We already discussed about this. We got emplace, empty, friend. These are some operations we can perform on this queue. We can use this empty, whether check whether the queue is empty or not. So by that, by using this empty, we can traverse the queue. So while queue empty not equal to empty, empty returns 1, empty returns, sorry, it returns 1 on if the element is empty, if it returns 0 if there are something in it. So let's print out some values. See out q dot friend. Friend, the friend part is nothing but the element, the one which we pushed first. Here it is 1. We pushed 1 first. So when you see out q dot friend, then the first value must be 1 because it is at the friend. Add a new line and let remove that first, the friend element. You can remove that by pop. Pop is nothing but DQ. We got it right. Push, NQ, pop, DQ. And the front one returns the front element. The back one, Q also has Q dot back. As you can see, it returns the back element. That means here it is 3. Okay. Let's try executing this. We are getting some error here. Okay, my bad. It's a silly, very silly mistake. I did not save the file. As you can see here, it's showing a white little dot here, right? I did not save the file. Let's first save it. Now, as you can see, we got the output 1, 2, 3. I'm sorry, guys, for that mistake. So this is how you implement a queue in C++. The first thing you need is a header file queue, which consists of the data structure queue, and then you input a data type. It can be anything, a string, a float, anything. Here we took end. Then you push it. You can traverse the queue like this. Empty returns, whether it is empty or not. That's it, guys. That is how you can implement queue in a C++. Let's see an example on queues, a problem on queues. The problems. Let me zoom in. Okay, print binary numbers from 1 to n. I hope you all know what a binary number is. As you can see some examples. Let me show you one pic. As you can see here, this is a binary number and its corresponding decimal number is addition of, summation of all this. One corresponds to 2 power 0, 0 to 2 power 1, and so on, 2 power 7. Summation of these 2 power 0 to 2 power 7 gives you the decimal number of this binary number. I hope you got what a binary number is. So what was our question? Print binary numbers from 1 to n. So the approach, the idea here is we'll have a queue. Okay, and we push 1 to it first. We have 1, which is the first binary number in the queue. And if you add let's assume that this one is a string. No, just remove what I said. If we add 1 0 and 1 1 to the queue, then we got the next binary numbers, right? 2 and 3. So what we are doing right here is we are appending 0 as well as 1 to the initial value 1. Here we have the initial value. We are appending 0 and 1 to it and pushing them into queue. Now we got 2 and 3. This process continues. Now we append 0 and 1 to this 1 0. We append 0 and 1 to this, and so on till we reach n, a number. You got it, right? The approach to this problem. Any doubts in this approach? First we push 1 to it, then pop the 1, and then we add 1 0, which means we are taking the initial value 1 and adding 0 to it and adding this whole value, and we are pushing this 1 0 to queue and then 1 1 to queue. You got the approach, right? Any doubts? Okay, if no, I'm proceeding with implementation. So in the question, it is asked print binary numbers from 1 to n. So we need n, the ending value int n. Let me take the input. We took the input. Okay, now we need a queue, right? We thought of having a queue and then pushing 1 to it initially. So let's have a queue int, since we are working with integers. So let's call this binary. Now we thought of pushing 1 to it initially, right? So binary dot push 1. So we have one in our binary queue. Then we need to append 0 to this one and 1 to this one, and then push it into the queue. It's a bit more complicated if we use integers, but if we use strings, we can directly use string functions append 0 and 1 to it, right? So let's use string here. String. So we'll input 1. We got 1 in the we got 1 in our queue. Let's move. We want to reach the end, right? So while n minus. Then what we want to do, we want to first output it, log it. So cout binary dot friend returns the friend value, and then I'll okay, we printed it out, and then we need to add 0 and 1 to the existing value and push it into the queue. So okay, we'll take string s equal to binary dot friend. This string s is initially 1. We only have 1 here initially, so we need to append 0 to it, right? So q dot binary dot push s dot append. So we thought of appending 0 and 1 and pushing both. So we'll append 0 to it first, and then append 1. I think it won't work because after we append 0 here, the string is going to change. So we need another string for this thing to work. So let's have a s1 equal to s. So after appending 0 to s, it is now 1 0. We want to push 1 1 to the queue, not 1 0 1. Right? Here we are pushing 1 0 1, not 1 1. So if we say s1 dot append, then s1 is nothing but 1. So here we are pushing 1 1. Okay, that's it, I guess. This should be able to generate all the binary numbers from 1 to n. Let's run it. Save it first. Okay, we'll input first. What is that we need to input? N. So I want 1 to n, 1 to 5 numbers. So let's say, okay, there is an error. What is this? We are pushing. We are appending to it. Everything seems perfect right here. Okay. Anyone got any ideas where the error is? See this code clearly. Think about it, where the error is. Anyone? Anyone? Nope, no one? Please type something in the chat box. Okay, I'm gonna take that as a no. So we missed pop. See here. We thought of popping it, right? So we missed the pop. After printing it out, we need to pop it. We don't need one anymore. So let's pop it. Now it should be okay. Let's n equal to 5. You see, 1, 2, 3, 4, 5. It works. Let's try again for satisfaction. Let's go with 10. See, 10. This is a 10. 1 to 10. Everything's right. Okay, now we have so far seen queues and a problem on queue. Now I hope you got how to use queues on how to implement queues in C++ and how to solve problems like this. Okay, now we'll move on to priority queues. Okay, priority queues. As I said earlier, this queue consists many different types of queues. It also consists priority queues. Okay. Priority queue also takes a data type which we want to use. These are templates, guys. In the previous sessions, we already discussed this templating thing, template functions, template classes. So in here, well, let's work with ints first. Let's say PQ, priority queue. Priority queues are nothing different. They only have priority when compared to normal queues extra. So a priority queue initially, mm, the highest element, if we take 5, if we compare 5 and 1, the 5 is the biggest largest number, so 5 has the highest priority initially. That's the default in priority queues. If you want to change that thing, we can change. I'll show you later. So 5 has the highest priority and 1 being the lowest priority, which means if we have 5 comma 1 in our queue, 5 should be 5 should be we should be able to print 5 first, then 1. We should be able to remove 5 first. That's one. Okay, let's push something. Same push and pop, push NQ, pop DQ. Let's push 1. Let's push 5. Let's push 3. And priority queue has also empty thing, this empty function which returns whether the function is empty or not. So we can use a while loop, pq.empty, and then cout pq.friend. No, it has no friend, guys. It has stop instead of friend. Both things are, same things. But the thing is, priority queues, they are implemented efficiently in C++. They are not implemented like arrays. Like you don't have values like 1, 2, like an array. You don't have. The internal structure is not an array. It uses something called heap trees. Now, what is heap trees? Well, it requires its own session actually. So I'm not gonna get into much more details about heap trees, but we'll discuss about what is heap tree in the future for sure. So it uses priority queues. This priority queue in C++ uses heap trees internally. Why heap trees? Well, let's take an example. You implement priority queue in an array, like arrays. Internally, it is implemented like arrays. So arrays means we have values like this, 1, 2, 3, 4, and then allocated like this. They have indexes, right? Now, if you want to push 5, right? We have this in queue, 1, 2, 3 in a queue. Now you want to push 5. Now, depending on the priority, the element should be placed, right? Now 5 should be placed here. If you ask me, 5 should be placed here. Why? Because it has, highest priority. But if we use arrays, we need to check all this, right? We need to compare 5 with 1. Okay, 5 is greater than 1, so it has highest priority. Move on to next element, 2. Okay, 5 is greater than 2. Move on to next. Okay, 3. We got 3 is less than 5. And move next. Nothing else found. Yeah, place 5 there. This is what happens if we use arrays internally. So that is why we use heap. Internal implementation uses heap. In heap, the element, the structure is totally different. No, that's not. They are, arranged in trees. So in such a way that if you want to enter 5 in this case, 1, 3, 5, you don't need to check, 1, 3. If you have 4, 6, you don't need to check all these elements to enter 5. We need to check only, few elements. Understand that. In a heap tree, you don't need to check all those things, all those elements in the queue. We need to check only some elements in the queue, such to insert a new value, which means we are doing the operation in less time. Complexity of this heap tree is less. That is why we internally C++ uses heap tree. If you want to learn more about heap tree, you're just one Google search away from it. But do it after this video. Okay. Then I already said already told it has no friend, but it has top because it uses the heap tree. Tree top means topmost element in the tree. Okay. We're just trying to print here. So let's pop it out. We're trying to print the top element and then remove the top element from the cube. So let's print it. It's not binary. As I said earlier, 5 being the highest priority element. You can see here 5 is outputted first, then 3, then 1. If we have, let's take more, push more things. Now, if you take 10, 10 is larger than all the other numbers. It should be, the first thing it outputs. See, we got 10 here, then 8, then 5, then 3, then. But what if you want, one has your highest priority level, highest priority element, then basically we want is reverse of this, right? We want 1 to be the highest priority element, then 3, then 5, and so on. To do that, by default, it's like this. The largest number has highest priority. Let's do that. Okay. Two things here, vector int, which means we are priority queue uses, vector-like implementation. As you all know before, you don't need to worry about that. It always stays this. We just passing it. Passing it because we need to pass. It won't work if we remove this, right? We need to pass the structure. Okay, then we have one more thing, greater. What does this greater do is all the high bigger elements, 10, 5, 8, these elements are pushed towards the back. As I said earlier, back back is where you insert, right? In a queue, in a normal queue, back is where you insert, and front is where you dequeue, where you remove. So what this by passing this, what it does is it pushes all the bigger elements towards the back. So if we entered 1, then we entered 5. 5 is it's bigger number than 1. It's largest number, so it's pushed towards the back. Then 3 falls behind 1. Then 10, then 9. You get the point, right? Let's run this too. No, I did not save. See here. Right, we got 1, we got 3, then 5, then 8, then 10. The 1 being the highest priority element, 10 being the lowest priority element. Okay, we'll move on to the next example. Okay, we'll solve one problem. The question is quite big. Assume that you are in a hospital and waiting in a line for your turn. Okay, you're in a hospital You are waiting for your turn so that you will be get treated. Doctors in the hospital want to treat critical patients first. Okay, doctors don't want to waste time on, simple stomach pain. They want to, treat severely injured patients or patients whose condition is critical. So what we want to do is here we want to print who gets treated when. Okay. Mm, what the input to this program is, each line consists of an integer which shows patient's condition. Okay. Lower is the integer, higher is the patient's bad condition, which means if we have 1, then the patient is, definitely going to die in a couple of minutes. Okay. Then if we have 10, then, we can wait. We can treat other patients who are in critical conditions. You got it right, the question. Now, given the input, we want to print who gets treated when. So in an okay, -1 in the input means end of incoming patients. Okay, which means patients are coming to the hospital, and when we encounter -1, which means when we encounter the integer -1, then we got all the patients. The problem assumes that the doctor only treats when all the patients arrive. This is only for the sake of problem. It won't happen in the real world. You all know better than me, I guess. So we got vector. We don't need that actually. We need Q. We need Q header file. Yes, we need. We need IO stream for, printing out. I did not tell you about this functional thing, right? Let me go back to the previous example. Here we used greater, right? This greater comes from this header file function. It has functional. It also has less, z less. This comes from here. Remember that. Okay. Each line consists of an integer. Okay. When we encounter -1, that's the end of patients. Okay. We want something okay. Let me take a queue, priority queue, because we need to, treat the patients who are in critical conditions. We have some priority here. Doctors have some priority here. So we need to use priority queues. We can also use, the old way where you can take all the inputs. So if the input is 1, 2, 3, 4, you can take these inputs and you can just sort them in ascending order. Patient with, what is condition 1, critical. 1 means he's in a bad condition. 1 integer states patient's condition. So the patient with integer 1, the condition 1, will get treated first. 2 in the second, 3, 4, 4. This is simple if we know the input. We know all the patients beforehand. Here we don't know how many patients we are gonna get into a hospital. So they gave -1, such that we'll stop at that step. Okay, let's use priority queue. We are working with int. Okay, and as I said earlier, we need to use greater because we want all the largest elements to move back. We don't want them in the front side. We want them in the back lines. Okay, well, let's call this P conditions, patient conditions. We got the queue. Okay, let me iterate. Okay, we don't know how many patients there will be, so we'll use a while loop. One, this loops infinitely. So we need a condition to break. The condition they gave is -1. So let me take input condition. This is a single patient's condition. So see condition. Okay, we got the condition of a single patient. Now we need to know whether condition is -1 or not. If it is -1, then we need to break, right? Patients are done coming into our hospitals. We don't want any patients. That only happens here. We can also use less than 0. If it is less than 0, we break. We don't want any more patients. And if it is not, we have to push. Dot push and push the condition. No, not this. That's that's it, I guess. When we encounter -1, it breaks, and we have all our patients, sorted by their, condition, how bad it is. In this queue, P conditions, patients conditions. All we need to do is right now, just iterate over them. Let me say doctors treating. Okay, let's iterate over them. P conditions dot empty. You know empty. You know the drill, right? Okay. Let's see. Let's say patient with condition. The condition is P conditions dot top. The highest priority patient is being treated. Then a new line. Then we need to remove that after. We don't want patient to be in a hospital after being treated, right? We don't want it. So P conditions dot pop. We don't want you. Then that's it, I guess. We should be able to get correct answer. Let's save it and run. H. They take input conditions. Okay. One patient has condition 10, which is good. Is not that bad. Is not in that bad condition. A patient with condition 5, a patient with condition 1, a patient with condition 7. Well, that's it. We don't want any more. -1, which means we have 4 patients. As you can see here, after we get the 4 patients, the patient with condition 1, which means the patient who is in critical condition, bad condition, is being treated first, followed by the next highest, the next bad condition patient. Okay, you get the point, right? Here you got the correct output. Okay, that's it. This is priority queues. This is queues, normal queues, priority queues. Okay, I think that's it for this session. Pretty small one compared to other ones, previous sessions. I can tell you, I challenge you guys, to implement queues in C. I think you all are familiar with C. In your first semester, in the first year, you might have learned about C. Here we are just using the queues. They are already implemented in C++. We are just using them. But I want you guys to implement this queues and priority queues, in C, where you do not have the default data structure like this. It can be challenging, It's a good challenge, and you should be able to do it. It's not that tough. It's not that easy. It's doable. So you do that. It will give you what exactly a queue is, what exactly a priority queue is. That's it, guys. I guess for this session.